Here's a short video in which I will show you what you need to highlight on the summary. And the summary for page Unit 2, Lesson 4. So on the summary, it's the orange page, equations and their solutions. An equation that contains only one quantity and it can vary in one variable. So let's go ahead and highlight that. An equation contains only the unknown quantity and one quantity that can vary is called an equation with one variable. For example, the equation 2 times L plus 2 times width is 72 represents the relationship between length and width of a rectangle that has a perimeter of 72 units. If we know that the length is 15, we can rewrite the equation as 2 times 15 plus 2 times the width equals 72. This is an equation with one variable because W is the only quantity that we don't know. To solve this equation means to find out what the variable of W is that makes it true because it has one variable. And then here in this example, they went and they did the math, the algebra, to determine that 21 is what the width is. And when you sub in 21 for where the W is, you find that the solution 72 is in fact correct. An equation with two unknown quantities, so now we're going to highlight this next one. In addition, an equation with two unknown quantities or two quantities that vary is called an equation with two variables. Go ahead and highlight that. So there are one equations and there are equations that have two variables. A solution to such an equation is a pair of numbers that make the equation true. So suppose Tyler spends $45 on t-shirts and socks, and a t-shirt costs 10 and a pair of socks costs $2.50. If T represents the number of t-shirts and P represents the pairs of socks that Tyler buys, we can represent this situation with the equation 10 times T plus 250 times P equals 45. This is an equation with two variables. There's more than a pair of values for T and P make the equation true. So here we're subbing in 3 and 6 for our variables T and P, and we're solving, and we find that 3 and 6 do make the equation true. And when we use 2 and 4, we actually have another situation that makes the equation true. And we have 2 and 10, we also have a situation that makes the value true. So in this situation, one constraint is that the combined cost of socks must equal $45. The solution to the equation are pairs of T and P values satisfy the constraint. So when we did combinations with 1 and 10 and 2 and 7, we found that they are not solutions because they don't meet the constraint. When these pairs of values are substituted into the equation, they result in a number that is false. So that concludes the summary of what we were learning in Lesson 4.